Hello dear students, I'm M.اسماعیل, a physics teacher at Typical English School. Today I will solve some mini-star question for you. This question is about 2025 year at first round. At the beginning, now I'll solve question 3. Question 3 is about chapter 2, so it's about equilibrium subject. A meter stick is supported at its 50 centimeter mark by a vertical string, okay, attached to a ceiling. At the beginnings, we have to draw a stick. We have a stick, okay, we have a stick, length of 1 meter, okay. The length of the stick equals to 1 meter. But we have to convert to centimeter. So 1 meter equals to 100 centimeter. Okay, but we have to classify this stick to 10 equal parts, such as 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 centimeter. This stick is hangs at point 50 centimeter at the middle of the stick. This stick is hanging with a vertical, at the vertical string or a rope. We know that each rope or each thing has a tension force. Its direction, it's always to the upward direction. Okay. After that, a 1.2 kilogram mass hangs from the 70 centimeter. This number is very important, and this is our first mass. The first mass of 1.2 kilogram hangs from the 70 centimeter mark. 70 meter mark, it's located at this point. This first mass is 1.2 kilogram. After that, a 0.6 kilogram mass is attached vertically from the 30 centimeter mark. 30 centimeter mark located this point. This is the first mass is 0.6 kilogram. A 0.4 kilogram mass should be at which location on the stick to protect or to provide translational and rotational equilibrium. The third mass, M3 equals to 0.4 kilogram, must be at what location? We have to find the location of the third mass. This means that we have to find the distance between the third mass and the axis of rotation. This point is the axis of rotation and located at the middle of the stick. Okay. After drawing the stick, we can solve the equation in an excellent way and a shortest way. Okay. To find this distance, we have to find the second condition to equilibrium. Summation of torque must be equals to 0. This means that the torque to the counterclockwise equals to the torque to the same direction of clockwise. The torque to the counterclockwise includes M2, M3, and M1 to the same direction of clockwise, but M2 and M3 to the direction of counterclockwise. Okay. Under counterclockwise, you can write 0.4. Okay? 0.4 times D. But we have to convert to weight. Times D, this unknown, plus 0.6 times 0.81 times what? What's the distance between the second mass and the center axis of rotation is 20 centimeter. Is 20 meter. Equal. The face mass is 1.2 kilogram times 0.981 times, what's the distance between the face mass and the axis of rotation is 20 centimeter. Is 20 centimeter. Okay. To find the 9.81 is cancelled with 9.81. Okay. To find the D equals to what? The amount of D is transferred to denominator 0.5. 1.2 times 20. Okay. This amount is positive, which transfers to the left side becomes negative. 0.6 times 20. And we get D equals to 30 centimeter. But this number is the distance between the third mass and the axis of rotation. But the question required to the mark. The distance is 30 centimeter between the axis of rotation and the third mass. But at the same time we can write the third mass must be hangs at 20 mark. At 20 mark. Or 20 mark. Centimeter mark. 20 centimeter, dear student, is equal to the distance between the axis of rotation and the third mass. Section or option A, at mark 20 centimeter, it's correct. B, at mark 30 centimeter, it's not correct. C, at mark 40 centimeter. D, at mark 80 centimeter. Option B, C, and D are incorrect. The correct answer is option A, at mark 20 centimeter. Thank you. Hello dear students, I'm م.اسماعیل, a physics teacher. Today I will some ministerial question about our chapter 4 for the 12th grade of physics. Now I will solve question 1. Question 1 is about a ministerial question is about of chapter 4. The distance between two adjacent wavefronts is equal to dash. A 1 lambda, to B 2 lambda, C 1 over 2 lambda, D 1 over 4 lambda. We have an important notes. The distance between two adjacent wavefronts of sound equals to what? 1 lambda. Equals to what? 1 lambda. The correct answer is option A. But how do you know? How do we? We have to explain. What do you know? What do you know? You can select A. Okay. We know that each sound of source, okay, is propagated in 3 dimensions. Okay? First dimension, second, and third dimension. This region, these circles is called, okay, wavefront. It's called what? Wavefront. Okay. The distance between the two adjacent wavefronts of a sound wave is called or is equal to 1 lambda. Again for you. We know that each sound source, okay, is propagated in 3 dimensions. Okay. This circle is called wavefront. The distance between two adjacent wavefronts of a sound wave equals to 1 lambda. Therefore, we can select option A. Option A, it's correct. Okay? Thank you. Hello dear students, now solve question 2. It's about chapter 4. Chapter 4 is about sound waves. Okay. A police car emits a sound of frequency 1130 hertz. This is, we have a sound of source, or source of sound, or we have a sound source. A police car has a rule of source. Okay. This cars emits a sound, sound of frequency. This is the frequency of the source, 1130 hertz. Okay. What the speed of the car can we have in order to a person standing on the sidewalk? What is the velocity of the sound of the car? No sound, V or source. We have to find source of the what? So we have to find speed of the source, not of the sound. Okay? After that, on the sidewalk to here, when the person standing it means V naught equals to 0. Or we can say when the observer is at rest, this V naught equals to 0. Why? Because the observer is at rest. Okay. At the frequency of 1200, this apparent frequency equals to 1200 hertz. This is heard by the observer. If the speed of sound in air is 345 meters, if the velocity of the speed of sound is 345 meters per second, what is the speed of the car? What is the speed of the car? At the beginning, we have to write the main rule of Doppler's effect rule. Okay? F dash equals to F times V minus V naught, V minus Vs. Look at her. Because the observers or the person is at rest, okay? Is at rest. We can write V naught equals to 0. So the source is moved toward the observer. V becomes positive. Positive times negative equals to what? Equals to negative. Okay. F dash we have equals to what? 1200, sorry. F we have 1130 times speed of sound in air we have 345 minus 0. Okay, so we have 345 minus Vs. Vs is unknown, but how do you know? How can find it? Okay, by multiplication, okay, equals by cross product, we get that this number minus 0 equals to 345 and times 1130. Okay, 1130 times, okay, 345 equals to 1200 times 345 minus 100 times Vs. Now we can find Vs. Vs is the speed of sound is what? 25 meters per second. 25 meters per second is the sound of the police car. And again for you. We have a police car is moved towards a stationary observer. V naught equals to 0 because it's at rest. Okay. With frequency of 1113 hertz. The frequency that held by the observer is 1200 hertz. Okay. What's the velocity or what the speed of the police car when it moves toward the observer? At the beginning, we have to write the main rule of Doppler. F dash equals to F times V minus V naught over V minus Vs. So the speed of the sound is positive because the Pōly scale is moved to the observer. F dash we have, F we have, V we have, we can find speed of sound of the car and its quantity equals to 25 meters per second. Thank you. Hello dear students, now I'll solve another question of chapter 4. This question is a ministerial question to the year 2025 first round. This is an excellent, a new thing or a new question about chapter 4. This question is about a decibel level. Question 3. The decibel level of the sound wave produced by a trumpet is 30 decibel. 30 decibel. B1 equals to 80 what? Decibel is the unit of decibel live. At distance 5 centimeter, this is R1 or phase distance equal to 5 centimeter. What's the decibel level of this sound at distance 50 centimeter? What is the decibel live, okay, at distance R2 equals to 50 centimeter? This question can be solved in two different ways, but now I will solve this question for you in an excellent way, in a shortest way. Please join me. R1 square over R2 square, okay, equals to 10 power B2 minus B1 over 10. 10 is constant. R1 square we have, okay, 5 square over 50 square equals to 10 power. B2 we haven't, B1 we have 80, divide by 10. 5 square equals to 25 over 2500 equals to 1 over 100 equals to 10 power, okay. B2 minus 80 divided by 10. We know that 100 equals to 10 power positive 2. When transferred to denominator becomes 10 power minus 2. 10 power minus 2 equals to 10 power B2, okay, minus 80 divided by 10. This base is equal to the right base. We can write minus 2, okay, equals to B2 minus 80. B2 equals to minus 2. 80 divided by 2 equals to what? Equals to 8. $80 divided by 10 equals to what? 8. Plus what? Minus 2 equals to B2 minus 80 divided by 10. We can write B2, okay, minus 80 over 10 equals to minus 2. By cross product, minus 20 equals to B2 minus 80. We get B2 equals to 60 decibel. We could solve this question in a new way, in a shortest way. B2 equals to 60 decibel. The correct answer is 60 decibel. Question 4. The frequency difference between two adjacent harmonics in a pipe plus add 1 in equals to one of the following. The phase difference. The difference of frequency of the pipe, okay, at close one end equals to 2 times of fundamental frequency. I again for you. Change in frequency or the difference of frequency in pipe close at one end equals to 2 times of fundamental frequency. Why? Because we know that the first harmonic is 1, after that becomes 3, becomes 5, becomes 7, becomes 9, becomes 11. This is a single number, okay, or odd number. The difference between two adjacent frequency, 3 minus 2 equals to 2, 7 minus 5 equals to 2, 11 minus 9 equals 2. We can say the difference between two adjacent, between two frequency at pipe close one end and every time equals to 2 times of fundamental frequency. Option A, fundamental frequency, it's incorrect. Half of fundamental frequency, incorrect. Twice of fundamental frequency is correct. The correct answer is option C. Now I will solve question 5 because I solved question 3. What fundamental frequency in a 2.45 meter long pipe that's open both of ends? We have two types of pipe. Pipe, both ends, pipe cross add one ends. This pipe is what? Pipe, you have to write on your paper, pipe, both ends. Both ends. Okay. The length is 2.5. L equals to 2.45 meter. This is a length of the pipe. Okay. You have to separate between the length of the pipe and the wavelength of sound. Okay. So the speed of sound in air 345 meter. V equals to 345 meter per second. This is a sound of speed of sound of this is the speed of sound in air. Okay. What's the unknown part of this question? Pipe that's open both of ends, fundamental frequencies. What is the fundamental frequency? We have to find F1. F1 equals to, we have to find it. Okay. At the beginning, we have to write the fundamental rule or the essential rule of F. F equals to Fn equals to n small v over what? 2L. Because of the pipe open both of ends, open at each ends, we have to use this rule. F sub n, F1 equals to 1, okay, times V. What's the amount of V? V equals to 345 meter per second. 2, it's constant. L equals to 2.45. We get to F1, okay? F1 equals to what? 70 hertz by using your calculators. We can say the correct answer, option A, is 70.4 hertz. Question 6 is a ministerial question to the year 2025 first ground. A bird flying toward a fixed wall emits a sound. The reflected wave, this word is very important. The reflected wave, or sometimes it's called echo, that received by the bird is one of the following. We have a bat. Bat is a bird, okay? Is flying toward a fixed wall. A fixed wall, okay? The reflected wave, okay, or the received wave, reflected wave, according to the plot, is correct about one of the following. First, its frequency is less than the frequency of the original sound. We know that F dash is always larger than F. But option A is written its frequency is less than the frequency of original sound. It's incorrect. Its intensity is greater than intensity of original. It's incorrect. But the intensity is less than the intensity of original sound. Both of A and C are correct. We can select option A is correct. Why? Because F dash is always larger than F, but the intensity or I dash is always smaller than original R. Why? Because we know that intensity of sound is inverse proportional with the square distance between the source and the point. So the distance in this question is increased. Because of the R is increased or distance is increased, I must be decreased or increased? Must be decreased. Therefore, we can select option C. All of the following are characteristic of sound except. Dear students, this word is very important. These of the following are the characteristic of sound wave except. You have to select one of this option that's not characteristic of sound because you have to look at except. Okay. Mechanical wave is a characteristic of wave, of sound wave. Longitudinal wave is correct about characteristic of sound, but we have to select a characteristic is not characteristic of sound wave. Travel through solids, liquids, and gases. It's correct, but we have to select an answer opposite to the answer. C, transverse waves. We have to select option C. Why? Because sound is not transverse wave. Sound, we know that sound is the mechanical longitudinal wave. But option C is right in transverse wave. It's incorrect. Therefore, we can select option C is correct according to this question. Okay? Thank you.